Question number 5. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. However, the test also yields a false positive result for 0.5% of the healthy person tested. That is, if a healthy person is tested, then with probability 0.005, the result will imply he has the disease. If 0.1% of the population actually has the disease, what is the probability that a person has the disease given that his result is positive? So we have two things here. One is the person has the disease and the person does not has the disease, isn't it? A laboratory blood test is 99% effective in detecting a certain disease when it is present. So when it is present, 99% is accurate in detecting that a person is having the disease. However, the test also is a false positive result. Though we don't have, but there is a percentage to show that for a healthy person, he has the disease. That is 0.5% of the healthy person tested. So I am underlining what all the points important. Then if 0.1% of the population, so population we have 0.1 that is actually has the disease. What is the probability that a person has the disease given that the result is positive? So what are all the things we have underlined? 99% the disease accurately the test result shows positive, and 0.5 it shows positive for a healthy person. Okay, and we have 0.1% of the population has the disease. These are all the points. So it is known that population 0.1% has the disease. Okay, what is the probability that a person has the disease given that the result is positive, given that the test result is positive, given that. So that will be our A. Okay, so now what we have to write? Let A, so question number 5, let A be the event of getting the test result positive. Now we have to identify what is E1 and E2. It is not necessary to have E1, E2. It's up to you whether you are going to choose E1, E2, etc. Now, here as it shows the test results, 99% it is detecting correctly and 0.5% it is detecting false. What we have to take? E1. So let E1 be the event of selecting a person that has the disease. What will be the E2? If my first event that a person has disease, then the opposite will be person does not have the disease. Person does not have the disease. As we have underlined the main points, let's first come to the thing. So E1 I have taken person has the disease. And what was the last line? If 0.1% of the population has the disease. Sorry. 0.1% actually has the disease. So what will be my P of E1? It will be 0.1%. So 0.1% is 0.1 by 100, or you can have it as decimal, that's up to you. If 0.1 is the person has the disease, my E2 does not have the disease. Okay, to find P of E2, it's simple that we can minus from the E1, because as E1 has the disease, person has the disease, E2 is person does not have the disease. So like both are the complement, isn't it? So 1 minus 0.1 by 100. So that will be, take the LCM, convert into decimal or whatever the way you want. So that will be 99, 0.999, and here it will be 0.001. Okay, if you want as a fraction you can have, or that's up to you. This is P of E1 and E2. And A we have taken that test result is positive. Okay. Now P of A slash E1. That means a person has the disease and the test result is positive. What is given here? 99% effective in detecting a certain disease when it is in fact present. So the person has the disease and the test result 99% it shows correctly. So given the person has the disease and the test result shows positive is 99%. So 99%, that is 99 by 100. Either we can have it as a fraction or it's up to you as a decimal. And now what will be P of A slash E2 meaning? Given that the person does not have the disease, but the test result shows like no, for the healthy person also we have a false test result, that is a positive result 0.5. Test also yields a false positive result because the person is healthy, but we have it has to show it as negative, but we have an error here and it shows as positive. That percentage is 0.5 percentage. Though the person is healthy, the test result shows as positive. So that is percentage they have given as 0.5 percentage. So convert to the decimal or fraction and solve the answer. Okay. Now the question is, what is the probability that a person has the disease given that his test result is positive? That a person has the disease, we have to find. Person has the disease is E1. Given that the test result is positive. Test result positive is A. So given that the test result is positive is already occurred, in that the person has the disease. So since it is specific, we'll use the Bayes theorem. So mention as using the Bayes theorem. What will be the formula? P of A slash E1 into P of E1 divided by the sum. P of A slash E1 into P of E1 plus P of A slash E2 into P of E2. So that will be P of A slash E1, that is 0.99 into P of E1, it is 0.001. That will be in the denominator also 0.99 into 0.001 plus P of A slash E2, that is 0.005 into P of E2 is 0.999. Have it as a fraction and simplify, or have it as a decimal and decimate. So the final answer will be 22 by 133. You can leave it as a fraction for the probability. Okay, so we have three events here, that is 99% it shows positive for a diseased person and 0.5 false positive result for a healthy person. Okay, so in here itself we have three perspectives. One is the test result. The other one is person has the disease. Person does not have the disease. So this will be the main events. In that we have the test result positive for these two categories. So that's why we have A as the test result. I hope it is clear. Moving on to the next question. There are 3 coins. One is two-headed coin. So one is a two-headed coin having head on both sides. Another is biased coin that comes up head 75%, and the third is unbiased coin. One of the 3 coins is chosen at random and tossed. It shows heads. What is the probability that it was two-headed coin? So we have 3 categories. One is selecting the two-headed coin. The next is selecting the biased coin. Next is selecting the unbiased coin. That will be the main event. So question number 6. Because once we choose a coin, we'll have the probability, isn't it? Let E1 be the event of selecting the first coin. Okay. Let E1 be the event of selecting the first coin, that is two-headed coin. Let E2 be the event of selecting the biased coin, and let E3 be the event of selecting the unbiased coin. So now we need to find the probability of selecting the coins, isn't it? Because we don't know what type of coin we'll have. So in that itself we have the probability. So we have 3 sample space will be two-headed coin, biased coin, unbiased coin. N of S will be 3. And for P of E1, that will be favorable is 1, total is 3. So 1 by 3. Similarly, P of E2 favorable is 1, total is 3. P of E3, the favorable is 1, the total is 3. So all the 3 probabilities of choosing a coin is 1 by 3. This is the primary part. Now the second part is two-headed coin. That means the first coin has 2 heads. Now we have to say what is A. What is A here? How will you figure out? One of the 3 coins is chosen at random. Since here one of the 3 coins is chosen at random, we found the probability for choosing the 3 coins. Here for choosing the coins, I have totally 3 coins, and among that I need to find probability for individual coin. So N of S is 3, and my favorable is to choose two-headed coin. The probability will be 1 by 3. For biased coin, my favorable is 1, so 1 by 3. For unbiased coin, my favorable is 1, so the probability is 1 by 3. Okay, and here it shows heads. What is the probability that it was two-headed coin? It shows heads. So A will be the event of getting a head. Okay, so this is what A. Now I have to find, I know that it is two-headed coin. I should find what is the probability of getting a head. Okay, since it has 2 heads, it is 2 by 2, 1. The sample space also head and head, because for coins we may write the sample space as head tail, isn't it? So in that, probability of head is 1 by 2, probability of tail is 1 by 2. But here my head is also head, tail is also head for the two-headed coin. So sample space N of S is also 2, and my favorable outcomes head. So that is also 2. 2 by 2 is 1 for P of E1. And now I know it is a biased coin. What is the probability of getting hit? What condition they have mentioned here? 75. Biased coin that comes up hits 75 percentage. Suppose if they have mentioned tail 75 percentage, now you have to subtract from 100 with 75, then you have to write the remaining. But directly here they have given hits is 75 percentage, and our target is also hits. So 75 percentage is 75 by 100. You can simplify and write, or you can have as it is. And for the third, P of A slash A3. That is, I know it is an unbiased coin. Unbiased coin, you have this probability. I mean, sample space, head and tail. In that, I need to find the head, that is 1 by 2. Okay. So, we found what are all the events, what is A, what are the individual probabilities, and what is the conditional probabilities based on the question. And now the question is, it shows heads, so we know head is already occurred. What is the probability that it was two-headed coin? So since we have two events, one is already occurred, that means I know it is already head, and I need to find what is the probability that it was two-headed coin. That means E1. So P of E1 slash A. We have three events here. So P of A slash E1 into P of E1 in the numerator, and in denominator P of A slash E1 into P of E1 plus P of A slash E2 into P of E2 plus P of A slash E3 into P of E3. So this is the total probability in the denominator. Now we will substitute the values. P of A slash E1 is 1 and P of E1 is 1 by 3. The same in the denominator because the same term. Plus P of A slash E2 we found it as 3 by 4 and P of E2 is 1 by 3. Plus P of A slash E3 is we found it as 1 by 2 and that is 1 by 3. Simplify the terms and take the LCM whatever is needed, and the simplified value will be 4 by 9. Okay, this is the final answer. I hope it is clear. Now, the next question, 7th one. An insurance company insured 2000 scooter drivers, 4000 car drivers, 6000 Sorry for the interruptions. Yeah. Sorry, a technical fault. An insurance company insured 2000 scooter drivers, 4000 car drivers, 6000 truck drivers. So we have 3. The probability of an accident 0.01, 0.03, 0.15. One of the insured persons meet with an accident. What is the probability that he is a scooter driver? So we figured out 3 parts, isn't it? So now we have 3 events like in the previous question. Question number 7, that is, let E1 be the event of selecting a person insured as scooter driver. You have to write it fully, but here I am writing it short. Let E2 be the event that the selected person insured the car, or he is a car driver. Then truck driver be the event of E3. Okay, and since they have mentioned as accident, A will be the event of finding person meets with an accident. After we figured out what is E1, E2, E3 or how many events, what is A, then we need to find the probabilities. Okay, so totally the sample space will be scooter driver, car driver and truck driver. What is the total they have given? 2000, 4000, 6000. So it will be 12,000 in total. In that, to find the probability of a scooter driver, it is 2000 by 12,000. So that will be 1 by 6. And to find the car driver, it is 4000 by 12,000. They have given in the question. We are not finding by any means. So this will be 1 by 3. And P of E3, that is for the truck drivers, they have given 6000. So 6000 by 12,000, that is 1 by 2. And now we know that the driver is the scooter driver, and he meets the accident is 0.01. It is given again. P of A slash E2. We know that he is a car driver and it is given as 0.03, and given truck driver it is 0.15. Now one of the insured meets with an accident. So A is already occurred. What is the probability that he is a scooter driver? Scooter driver, again we have taken it as E1. Repeat the formula. P of A slash E1 into P of E1 plus P of A slash E1 into P of E1 plus P of A slash E2 into P of E2 plus P of A slash E3 into P of E3. This will be the denominator. Here again we are using the Bayes theorem because already the person meets the accident. What is that? The probability that he is a scooter driver. And that's the reason we are using the Bayes theorem. So substitute the values accordingly. So in numerator we have 1 by 6 and 1 by 100. Denominator 1 by 6 and 1 by 100 as a term, and 1 by 3 and I have converted 0.01 as 1 by 100, 0.03 as 3 by 100, 0.15 as 15 by 100 into 1 by 2. Okay, it's up to you, the simplification part. Not necessary to follow the way what I am doing. You can have it as a decimal, you can add and divide, or you can convert to fraction. Okay, so final answer is 1 by 52. Question number 8. A factory has two machines, A and B. Past record shows that machine A produced 60% of the items of output and machine B produced 40% of the items. Further, 2% of machine A, 1% of machine B were defective. I'm just underlining the points which and all we feel it is important for the question. All the items are put it into the one stock pile and then one item is chosen at random from this and it is found to be defective. What is the probability that it was produced by machine B? Okay. Here, a factory has two machines, A and B. That will be our even because with that only the question is based on. So let E1 be the event of selecting an item that is produced by machine A. E2 will be from machine B. And since they are talking about the defective, A will be the probability, event of selecting an item that drawn is defective. So you have to write fully. Here I am just writing it short. In exam you have to write like E will be the event of etc. Okay. And now to find the probability of E1, what they have given, machine A produced 60% of the items. Okay. Since our event is choosing the item produced by machine A, so it is 60%. That is 60 by 100 or 6 by 10 or 3 by 5, etc. It's up to you. P of E2 they have given as 40%, that is 40 by 100 or 4 by 10 or 2 by 5. Okay. So that is P of E2. And we know that A is the defective. And they have given that data also. Machine A produced 2% defective. So we know that it is from A and E1, machine A, that is defective, 2%. That is 2 by 100. We know that it is machine B and we are finding the probability that it is defective, that is given as 1%. That is 1 by 100. And now all the items are put into one stock pile and then one item is chosen at random from this and is found to be defective. Defective we have taken as A and it has already occurred. And what is the probability that it was from machine B? We need to find P of E2 slash A. That is P of A slash E2 into P of E2 in the numerator. Since we have two events, P of A slash E1 into P of E1 plus P of A slash E2 into P of E2. So what is A slash E2? 1 by 100, P of E2 40 by 100 by P of A slash E1 2 by 100 into P of E1 is 60 by 100 plus that in your bracket again 1 by 100 into 40 by 100. Anyway, we have 10,000 in the denominator. Here also we have 10,000 in the denominator, that gets cancelled. So we have 40 by 120 plus 40, that is 160. The final answer will be 1 by 4. Okay. Question number 9. Two groups are competing for the position on the board of directors of a corporation. So we have two groups. The probability that first and second group will win are 0.6 and 0.4 respectively. Further, if the first group wins, probability of introducing a new product is 0.7. The corresponding probability is 0.3 if the second group wins. Find the probability that new product introduced was by the second group. Okay. New product introduced was by the second group. Now the two events will be E1 and E2. Two groups are competing for the position, and the probability that if the first and second wins, that is what given. So let E1 be the event of first group wins, and E2 be the second group wins. And the new product introduced, that will be our A. So let A be the event that the new product is introduced. Now, to find the probability of E1, they have already given straight away in the question as 0.6. So that is 0.6 or 6 by 100 P of E2, sorry, that is 6 by 10. P of E2, that it is 0.4 or 4 by 10. Okay. And further, if the first group wins, we know that first group wins, the probability of introducing the product that we have taken as A is 0.7. And 0.3 if the second group wins. We know that the second group wins and the probability of introducing is 0.3. Find the probability that the new product is introduced. So this is already known. Was by the second group. So P of E2 slash A. Okay, here you have to understand properly. What will be the formula? P of A slash E2 into P of E2, the whole by P of A slash E1 into P of E1 plus P of A slash E2 into P of E2. Okay, so that will be 0.3 into 0.4 by 0. A slash E1 is 0.7, P of E1 is 0.6 plus 0.3 into 0.4, that is 0.12, 42, again 12, simplifying the terms, it is 2 by 9. It's the final answer. Okay. Let me know if you have any doubt in this part. Moving on to the next question, 10th one. Suppose a girl throws a die. If she gets 5 or 6, she tosses a coin 3 times and notes the number of heads. If she gets 1, 2, 3 or 4, she tosses a coin once and notes whether head or tail is obtained. If she obtains exactly 1 head, what is the probability that she threw 1, 2, 3, 4? Okay? Now, a girl throws a die. She gets 5 or 6, she has a task to do. If she gets 1, 2, 3 or 4, she has a task to do. 5 or 6, a task. 1, 2, 3 or 4, a task. So this will be our E1 and E2. So now, 10th question, P of E1, let E1 be the event that the girl gets 5 or 6. Okay, that is the main part, isn't it? Let E2 be the event of the girl gets 1, 2, 3 or 4. Okay, and the main thing is to find, she is noting the heads, and the second 1, 2, 3 or 4 again she is noting whether it is head or tail. If she obtained exactly 1 head, what is the probability that she threw 1, 2, 3 or 4? if she obtained exactly one hit, then A will be the event of getting exactly one hit. This is how we have to identify. Okay. Now, P of E1. Since it is a die, 1, 2, 3, 4, 5, 6. Sample space will be from 1 to 6. We need to find the probability to get 5 or 6. So the favorable outcome is 2, total is 6. So it is 2 by 6, that is 1 by 3. P of E2, our favorable is either 1, 2, 3 or 4. So 4 favorable outcomes out of total 6, that will be 2 by 3. That is the probability of getting 5 or 6 or 1, 2, 3, 4. And now, when she gets 5 or 6, she tosses a coin 3 times. Okay? And notes the number of hits. 3 coins now, what will be the probability, the sample space for 3 coins? Triple head, double HT, HTH. This you can do it in the rough column. It is not necessary to write in the main. Triple T, double TH, THT, HTT. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And here A is to find. This is she is throwing 3 times. If she gets 5 or 6, she tosses a coin 3 times. And the 3 times we have written the sample space. And now our task is to find the probability that getting a 5 or 6 has already occurred, and my probability is to find exactly one head. Okay, exactly one head. Now you will hit TTH, THT, HTT. So in these 3 only you will be getting the probability. Getting one hit, isn't it? So 1, 2, 3, and total is 8. Okay. Now we know that she is getting 1, 2, 3 or 4. What she is doing for 1, 2, 3 or 4? She tosses a coin once. She tosses a coin once. What will be the sample space? Head and tail. What is A? Exactly one head. How much we have? Only one head. The probability. Okay. P of A slash E2 will be 1 by 8. Is that as clear? And now we need to find if she obtained exactly one head. That means I know she already obtained the one head, exactly one head. What is the probability that she threw 1, 2, 3 or 4? That means E2. This is what we have to use. So you need to mention using Bayes theorem. P of A slash E2 into P of E2 by P of A slash E1 into P of E1 plus P of A slash E2 into P of E2. Okay. P of A slash E2 is 1 by 2. P of E2 is 2 by 3. P of A slash E1 is 3 by 8. P of E1 is 1 by 3. You can cancel the 3 if it is easy. P of A slash E2 is 1 by 2. P of E2 it is 2 by 3. Okay, we can cancel the 2's. Numerator I have 1 by 3. Denominator I have 1 by 8 plus 1 by 3. Taking the LCMs, cancelling the terms, the final answer is 8 by 11. Okay. Now, question number 11. Here we have 3 machines. A manufacturer has 3 machines, machine operators A, B and C. The first operator A produces 1% defective items, whereas the other two operators B and C produces 5 and 7% defective items respectively. A is on the job for 50% of the time, B is on the job for 30% of the time, C is on the job for 20% of the time. A defective item is produced. What is the probability that it was produced by A? So, how to start with the question? Question number 11. So, we have three events: E1, E2, E3 produces the items, isn't it? So, manufactured by A, machine A, E2 be the event that manufactured by machine B, E2 be the event, E3 be the event that it is manufactured by machine C. Since a defective item is produced, so A will be the event that item is defective. Okay, and now what is the probability that it was produced by A? Okay, and here 1% defective item is produced by A. I know it is from A and I need to find the probability that it is defective is 1%, that is 1 by 100. I know it is from machine B, the defective is 5%, so it is 5 by 100. I know it is from machine C, the defective item is 7%. These are all given. 7 by 100. Okay. And A is on the job for 50%, 30%, and C is on the job for 20%. That will be their probabilities, that is P of E1, because A is on the job for 50%, yeah. So that will be P of E1. B is on the job for 30%, so 30 by 100. And C is on the job for 20%, that is 20 by 100. Now, a defective item is produced. What is the probability that it was produced by A, that is E1? So, using Bayes theorem, P of A slash E1 into P of E1 by P of A slash E1 into P of E1 plus P of A slash E2 into P of E2 plus P of A slash E3 into P of E3. The value will be A slash E1 is 1 by 100 into P of E1 is 50 by 100 by the same terms for the first 1 by 100 into 50 by 100 plus P of A slash E2 is 5 by 100, E2 is 30 by 100 plus P of A slash 3 is E3 is 7 by 100 into 20 by 100 P of E3. Don't cancel the hundreds because the denominators are same. Is easy for us to calculate. So numerator it is 50, denominator is, because 10,000, here we have the same denominator, that will be cancelled when we take the reciprocal. So 50 plus 150 plus 140. So that will be the final answer. We can take it as 5 by sorry for the interruptions. It is 5 by 34. Next question. Before that, we'll do the 13th one. Okay. Probability that A speaks truth is 4 by 5. A coin is tossed. A reports that a head appears. The probability that actually head is, they have given the options. Okay. Probability that A speaks truth. Question number 13. Okay. So probably like E1 be the even that A speaks truth. E2 be the even that if first event is speaking the truth, second event is does not speak the truth. And they have given the probability that A speaks truth is 4 by 5. So P of E1 is equal to 4 by 5. How to find P of E2? It's complement, isn't it? Complement of E1. So 1 minus P of E1. That is 1 minus 4 by 5. That will be 1 by 5. Okay? So, given that, what it is given, a coin is tossed. Okay? A reports that a head appears. The probability that actually there was head. So here you have a chance. A coin is tossed. Okay? A reports that a head appears. So that will be an A. A reports that a head appears. He is speaking the truth for 4 by 5. Okay? Suppose he is speaking the truth. And we are getting the head. A coin is tossed. The sample space will be head and tail. So to find the probability that it is head and he is speaking the truth is 1 by 2. And he is not speaking the truth. He is lying. And our target is to find that head appears. Our target is to find head appears. But he is not saying the truth. So we have that also as 1 by 2. Complement 1 minus 1 by 2 will be 1 by 2. Because for head also 1 by 2, tail also 1 by 2. Okay. A head appears, the probability that actually there was a head. Actually there was a head means what we have to find. He's saying the truth, isn't it? Actually head is like no head is tossed there. So that is actually head and he's speaking the truth. That's what we have for E1. So P of A slash E1 into P of E1 by P of A slash E1 into P of E1 plus P of A slash E2 into P of E2. That will be P of A slash E1 is 1 by 2 into P of E1 is 4 by 5. The denominator plus P of A slash E2 is 1 by 2 into P of E2 is 1 by 5. Don't cancel the terms because 2, 5 we have. Anyway, by 10 cancels. So 4 by 4 plus 1. That is 4 by 5. Okay. Any doubt in this? Answer will be option A, 4 by 5. Next, the 14th question. A and B are two events such that A is contained in B. So whenever I know A is contained in B, it's So we have two things. A is contained in B, or A is a subset of B. Union of two events will be B. Intersection of two events will be A. Because the total is B, isn't it? The elements that it contains. The set language, whatever we have studied in class 11. So, the probabilities also will be the same. P of A intersection B, A intersection B is A. So, that is what it's going to be the probability. Correct? So, P of A intersection B is P of A. Okay? P of B not equal to 0. Which of the following is correct? P of A slash B. We know P of A slash B is P of A intersection B by P of B. Okay. What is A intersection B we found? That is P of A by P of B. The simplified answer is, the formula for P of A slash B is P of A intersection B by, since occurred event is B, the denominator will be P of B. And we found that P of A intersection B is P of A because A is contained in B. Always the intersection, as we have studied in set language last year, it will be A. Probability also will be P of A. So when I substitute, I should get it as P of A by P of B. But here they have given us P of B by P of A. This option is not right. Okay. And now P of A slash B is less than P of A. Okay. And here, for sure, we know that even P of B is less than or equal to 1. Correct? Because the denominator is, for P of A slash B is P of B. And P of A is also going to be the same. Isn't it? So, we can conclude that this will be less than P of A. Because P of B in the denominator and that being the greater one, that is less than or equal to 1, this cannot be true. And now, P of A slash B is greater than or equal to P of A. Yeah, it can be equal to P of A or it can be, because P of A slash B involves P of A and P of B. Okay, P of A by P of B. Since it involves both the values, it can be either equal to P of A or greater than P of A. The option is option C. P of A slash B is greater than or equal to P of A.